Hey guys, so you will be looking at verifying identities. Now, if you saw on that first slide, I said with these lessons, there aren't as much conceptual notes, but tons of practice. The more you practice, the more you get better at these by strategizing and seeing the breakdowns of the problems. So when we go to verify identities, so this first one we're going to work on is secant squared x minus 1 over secant squared x equals sine squared x. You want to take the harder side of the problem and simplify it down so then you eventually get the other piece. Now, this sine squared x, you cannot touch it. It's like big red box. Sine squared of x stays the same. Everything you do is manipulating the left-hand side. You shouldn't have to multiply by things. What we can do is we will literally take those pieces and use the identities. All right? So let's get into the problem then. So you, as always, should have your identities out with you. The identity we are going to be looking at is we are going to first look at that secant squared minus 1. We see the secant squared minus 1, and what on your sheet does it show that secant squared minus 1 equals? Hopefully you see that secant squared minus 1 equals tangent squared. So, oops, I put theta. Once again, theta, x, alpha, beta, all of those are all the same. Okay, so now I've got tangent squared, and then that's over secant squared, and it still needs to equal that sine squared. So we're just going to keep that equal sign going. Now, what we see is that we have secant and tangent. We should change those into sine and cosines. So tangent is sine squared. Oops. See, I just want to put theta. Sine squared x over cosine squared x over 1 over cosine squared x. 1 over cosine squared x is the same thing as secant squared x. That's just the reciprocal identity. So we use the quotient identity in the numerator and the reciprocal identity in the denominator. Next step, we want to multiply that top and bottom. Before I do anything, I'm just going to do it like this. Multiply that top and the bottom by cosine squared x. Oops, cosine squared x over 1 over cosine squared x over 1. In order to make the denominator go away, then you actually get that cosine squared and cosine squared cancel, and you are left with your sine squared x, which is exactly what you meant to prove, and a little check mark means you verified it. All right, so make sure to put that check mark, put a box, put a smiley face, something that signifies the end of your proof. These are basic trigonometric proofs. All right, hopefully that one made sense. We'll go on and do some more. As I said, practice, practice, practice. You're going to have tons of problems to work on.